For number 2, you can essentially kind of, you can write it 2 ways. So for those of you that are going straight for this, oh wait, that's not the one I wanted. I wanted 3. All right, ignore that. That's the answer, by the way. I mean to do that. Okay, so if you look at number 3, look, for those of you, so this is a big OR. For those of you that want to go 8 over 3, right? You want to write that, but then what does it come out to? See how 8 is larger than 3? Yeah? Okay, how many fully formed W's are there? Meaning, how many full 3's are in 8? 2 of them, right? You have a 2, which is 3 over 3. I have a W, which is 3 over 3. And then how many W's would be your remainder? 2. 2 over 3, right? Okay, so you really have, okay, you kind of have that W squared, but that's what you want to look at it. So if I'm doing it over here, and you remember that root means how many you need to take whatever the base is out. So if you have 8 W's, I have W, 3, 4, 5, 6, 7, 8, right? I have 8 W's. If I can make 3, it comes out. So now I have 1, 2, 3, 4, 5. If I can pull a 3, I can bring it out. And so now, right, that's W squared. And now I'm left with W2 inside, correct? No, and now you have this 2/3. Remember, this W squared is just an integer, but if you wanted to write it as a fraction, this is the equivalent. These two are equal to each other. Because you need 3, right, for the whatever the base is to come out of the radicand. So, yes, W 8/3 is correct. Now we're dealing with W's here, so it's not like numbers, which we'll get to in a second, which is number 4. But you have to realize this is equivalent to this, which is equivalent to that as well. Here, at least you're identifying the fact that you understand you had 2 complete triple W's inside the radical. Do you guys kind of see the difference a little bit? Okay. All right, if now you're looking at 4 then, I have a cube root 8r to the 6. Okay, so before you get started, what if you can process that cube root? What is 8? 8 is 2 times 2 times 2, correct? Yeah. So can I pull that base out? So here, I can pull this out because it is a perfect cube root. I can go 2 cubed r6, right? Okay, so what about your r's? Can I pull any of the base r out?
No.
Well, how many do I need? I only need 3 for the base to come out. How many do I have? 6. Isn't that greater than 3? Okay, so how many of those can I take out? 2, right? Because this is equivalent, if I just put the R6 here. R6 is equivalent to, right? I have 2 complete R cubes in there. So this is really then 2R squared, and that is your answer to that. Okay, if you don't believe it, all right, let's do the fractions. So let's restart it. Okay, so this is an OR. All right, I have 8 to the 1/3, bless you, and I have R to the 6/3. Okay, right here you guys could see that I can reduce that, right? What's 6 divided by 3? 2. So happily, I do get that, right? But what's 8 to the 1/3? If it is a number base, you should be able to take it to a value. Let's wait for the cart to go by. You can always use your calculator. What's 8 to the 1/3? And it'll give you 2. So this you can even put in a calculator and it will give you that 2. Because you should know 8 is the equivalent of 2 times 2 times 2. That's 3 2s. So I can rewrite that 8 1/3. It's the equivalent of 2 3 3, and that is a 1, and there's my 1. So you're not wrong here. I know it's all messy. You're not wrong with this answer. It's not incorrect. It is correct. You just haven't simplified it to show your understanding of what a root is. And you didn't reduce it. I think the other one is what, 8? Is the other one 8? No. Oh yeah, 5. So now give 5 through 8 a try, and I'll do another one of them. Do I close it out? Yeah.